Okay, we're going to kick off our first video here for the math section. Alright, a few key words. Now there's several vocabulary words on this sheet, but there's a couple that just seem to come up all the time, so I want to make sure we're familiar with it. The word sum, S-U-M, that means we are adding things together. The sum of two numbers means we're adding those numbers. Difference. Difference means we are subtracting something. The difference between 10 and 4 is 6. How did I get that 6? I took the 10 and I subtracted away the 4. Okay? Factors. We're going to do factoring of different things in this little course. Okay? Let's look at the proper definition here. A number that is multiplied by another number. That doesn't really tell us too much. We're going to take bigger numbers and break them up into the multiplication of smaller numbers. Okay? Generally speaking, when we factor. And the multiplication of those numbers we refer to as the product of those numbers. Okay? Product means I'm going to multiply numbers together. Okay? Quotient means I'm going to divide two numbers. If I want to take the quotient of two things, I'm dividing those two things. Okay? We're all pretty good with the concept of whole numbers, I'm sure. We might throw in the word integer. Okay? That's like all the whole numbers, but it includes all the negative whole numbers. Okay? And then rational numbers, those are the good old fractions, okay? Numbers that can be expressed as a fraction, or we can express those numbers as the quotient of two integers, okay? It's a little more properly stated. All right, good deal. I'm going to be off and on kind of throwing my notes in front of the screen here and throwing just a blank piece of paper so I can write on it in front of the screen here, okay? So bear with me if I flip through and things like that at times. Alright, let's talk about the place value of numbers. Again, this is something that normally I would just write on the board, so I'm going to be doing maybe a little more borrowing from having you look at the book as opposed to me writing it than I normally would in class, so I hope you can bear with that. But this is a nice little chart of all the place values of a number, okay? If I have some big number here, and let me just write 3, 5, 6, 7, 9, 8, 0, 2, 1, 4. I gotta throw a decimal point in here somewhere. Point 5, 9, 6, 1, 2, 8. Okay, it's a big old number, right? Oops, you can't even see it all. It's so big. Let's go back out. Okay, and I just obviously pulled that number right out of the air. I don't even know how big of a number it is yet. I got to go back and fill in some commas here. Okay? Let's just talk about the place values I've got written here. We don't even have to talk about all of them. You got a nice chart there. Okay? Starting at the decimal point. If I start looking at the whole number part of this number, not the decimal. Okay, that first position we call the ones position. Okay? The number 1, 2, 3, 4, 5, 6, 7, 8, 9 until I get up to 10 there. Those all fall into the category of ones. Okay, the next one is the tens position. And then the hundreds. Okay? Ones, tens, and hundreds. The first three positions there to the left of the decimal. Okay? And if that was the only number there, you know, 214, right? 100. Well, if I bump it up a little bit, and that's not a good example. If I bumped it up one more digit, let's pretend there's something other than a 0 there, then it would be 1,000 something, right? So that's the 1,000 position. Okay, and I know you all know this. Quickie review. You're bored already. Don't get bored. We're going to talk about good stuff. So there's thousands, now there's 10,000. See, now it's okay with having that 0 there because now it's 80,214. So that's the 10,000th position. Okay, 100,000s, 980,000. Okay, and so on. I don't want to keep going here. All right, 100,000s. Okay, and as you look, million, 10 million, 100 million, billion. Okay, 10 billion, 100 billion, trillion. It keeps going, right? On the right side of the decimal, I didn't have as many digits written down here, but if you look now we're smaller and smaller and smaller, so this becomes a tenth, T-E-N-T-H, the tenth position. 0.5, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 7, 8, 9, that's all up in the tenths category. Okay, this would be the hundredths. Okay, 0.59, that means 59 out of 100. This one here meant 5 out of 10. 0.5, half, 5 out of 10. This means 59 out of 100. This means 596 out of 1,000. So this is the thousandths position. Okay? 10,000s, 100,000s, millions, etc., etc., etc. Okay? The farther we go to the right, the smaller these numbers are. Okay? So in other words, that's 596 out of 1,000. There's 5,961 out of 10,000. There's 59,612 out of 100,000. These numbers just keep getting smaller and smaller and smaller. Okay, and less interesting unless we're talking about something that's really small. Okay. All right, all good there. By the way, if I ever have to just kind of emergency quote-unquote stop the video because there's some ruckus in the background or something, unfortunately my software does not let me pause the video. So I would stop it and then I would just probably leave it right there and start a new video and continue, because it's going to be painstaking to have to go back and re-record a bunch of stuff. So there's no way for me to pause. Once I hit the stop button, that's it, and the video's over. So, okay, there we go. Very good. So place values. Alright, well, what are we going to do with all these place values? Well, we're going to round numbers to certain values. Okay? And we can also use these place values to help us compare numbers. Okay? Now, we all know, I'm sure we all know, if I say I've got the number 4, and I've got the number 4.05, and I've got the number 4.1, which one of those three numbers is the smallest, the middle, and the largest? I'm sure we're all familiar with that, right? 4 would be the smallest, and we would write a symbol like that to say 4 is less than 4.05, and that 4.05 is less than 4.1. Okay, this little symbol here is called less than. And this one's called greater than. Okay, greater than, less than. 4 is less than 4.05, and that's less than 4.1. How is that? This appears to be a bigger number because it's got 3 digits, right? Well, no. The decimal point's there. Anything to the right of that decimal point is just smaller and smaller and smaller increments being attached on there. But it's not making it a bigger number just because it has more digits. Okay? They all have a 4, so we're all at least 4. This one only has 4. That's it, 4. This one's got a little more than 4, 4.05, so 5 out of 100. That's 5 out of 100 there. Okay? This one has got 1 out of 10. Now, which decimal is bigger, 5 out of 100 or 1 out of 10? 1 out of 10 is bigger, right, than 5 out of 100. So 4.1 is larger than 4.05. Okay, so we can use those place values to help us determine numbers and order of numbers, the proper order. Now this one would be a little easier to see. 32.47 versus 32.48. I mean, clearly now, if you had any doubt about up there, now certainly you don't have any doubt now. Right? Obviously that one's got to be smaller. It's just they're identical in form, except one of them's got a 0.47, the other one's got a 0.48. It's here where you might have to think a little harder. Okay? Greater than, less than. If you ever get confused about these symbols, just remember that the pointy part of the greater than, less than symbol, the pointy part always goes by the small number, and the open part goes by the big number, okay, or the large number. I think they teach the kids to put the little alligator teeth on there, and the alligator always likes to eat the big number. So that's one way to help you remember if you need to, okay? All right, sweet. So what about this business of rounding? Well, quite often we don't need, the level of precision of this crazy number I wrote at the top here. We can round it off somewhere. We just want to get close. We just want to get an approximate, okay? And the way we're going to round is, first of all, we have to know what position we're rounding to. I mean, that has to be established. Either we decide for ourselves or somebody tells us, hey, round it to the hundredths position. Round it to the 10,000ths position. I mean, you have to know what we are rounding it to. And then the procedure is, let's say we're going to round this number, for example. Well, let me get a fresh number. Let's say we're going to round a number. I've got a little example here that I'm in my book that I'm looking at off to the side here. Oregon. The state of Oregon has a land mass of 96,187 square miles. Okay, we won't worry about the units. 96,187 square miles, and we will worry about units later. Units are extremely important, but not right now. We're talking about rounding. Okay, so that's kind of a, I don't know how they calculated it exactly, but whatever. That's the accepted number of the square miles that make up the state of Oregon. Okay, well, let's round that off. Let's round it off to the nearest 10, for example. So here's the ones position and here's the tens position. So if I'm rounding to the nearest tens, that means I'm either going to leave that 8 an 8, and I'm going to turn the 7 into a 0, so I'm either going to call it 80 instead of 87, or I'm going to bump that 8 up to a 9, and I'm going to call it 90 instead of 87. So I'm rounding it to this position. When you do that, you must look to the number to the right of the number you're rounding to. So if I'm rounding to this tens position right here, I need to look at that 7 to the right, and that's going to decide for me how I round. If this number is 5 or greater, then I round up. If this number is 0 to 4, then I just leave that digit alone and I turn this one into a 0. So in this case, we need to round up. So rounding to the nearest tens is going to be 96,190. Okay, 96,190. Let's take that same number and let's round it to the nearest hundreds. Okay, so now I'm looking at this position here. It's either going to be 96,100 or it's going to be 96,200. I'm rounding to the hundreds position. Okay, so hundreds. Well, I look to the right. This number is bigger than 5, so I'm going to bump that up to a 2, so it'll be 96,200. Okay. How about to the nearest 1,000? Okay. Thousands. Oops, hundreds, thousands. So right there, I'm either going to leave it as 96,000 or I'm going to bump it up to 97,000. What do you think? I'm going to leave it as 96,000. Okay. And finally, let's do it to the nearest 10,000. So let me write it again down here. Remember, ones position, tens, hundreds, thousands, 10,000. So that means either the 9 is going to stay a 9 or I'm going to bump it up to a 10. Well, I look at the digit to the right. It's 5 or bigger, so that bumps up to a 10. So it's going to be, this is now in the 10,000ths position. So it becomes 100,000. Okay. Now, depending on your context, all of these answers are acceptable. How big is the state of Oregon? Well, you could say it's 96,187 square miles. I mean, right on the exact number. Or you can round it to any one of these positions. And again, depending on your context, you might just say, 100,000, close enough. Or you might want to be a little more precise and say 96,000, close enough. Okay, it depends on what we're doing as to what is considered close enough and what isn't. Okay? Alright, so that's rounding kind of a bigger number on the whole number side. What about the decimal side? What if I want to round a smaller number? What if I've got, let's say I've got the number 46.897, and I want to round that to the hundredths place. Hundredths. That's this one. Okay? tenths, hundredths. So I'm going to either leave that 9 as a 9 or I'm going to bump it up to a 10, and you see that's going to kind of shuffle some stuff when I do that. Well, I look to the right. That number is 5 or greater, so I'm going to make that 9 a 10, which turns my 89 into a 90. So 46.9, okay, 0. 89 turns into a 90, and when I'm on the right hand side of that decimal, I drop the remaining zeros after that. Okay, so I wouldn't want to write that 0. Now you say, what's the difference? And on a calculator or in many circumstances, there is no difference between those two numbers at all, right? And what we're doing here is rounding, so you probably wouldn't be taking a task on it. But in the world of measurement, there is a difference between these two numbers, because this number here is giving us a level of precision that we don't have. Okay, and we're not going to talk too much about that in this review course. But in the world of measurements, tacking zeros onto the end of a number like that, it means something. It means, wow, that's 46.900. Wow, you really know it's a 46.9. That's not a rounded number. That's, I mean, maybe it was rounded way down here, but wow, you really know some precision about that number if you measured it. Okay, again, we're not going to go into that too much in this course, but what we want to do is we'll drop any trailing zeros after we make the round. Okay, so in this case, rounding to the hundredths position, we're going to drop that third zero, that third where the 7 was. Okay. All right, let's round. If we talk dollars and cents, 293.48. Let's round that to the nearest tenths. Okay, so right here. Well, 48 becomes a 50. 293.50. We had to pay a little extra. We rounded up. Okay. If we rounded it to the nearest dollar, though, and okay, go back to the original, 293.48. If we round to the nearest dollar, the ones position, well, now we get to drop that chump change, right? And it just becomes 293. All right, all good? And let's do one more here. We've got, this is kind of a weird looking dollar figure. We're used to dollars and cents, but maybe some calculation or something gave us that $71.8986. You know, that doesn't make sense. We want dollars and cents. So let's round to the nearest cent, which would be our hundredths position. Well, that 89 is again going to bump up to a 90, right? So it'll be $71.90. All right. Good, good, good. When we add numbers with decimals, we just have to line the decimals up. Okay, if I were to add 24.68, and again, we have our calculator, so it's easy. With the calculator, you just plug those numbers in, but we line up the decimals here when we're adding or subtracting. So, you know, 8 plus 2 will be 10 there, carry the 1. That'd be a 6 there, carry the 1, bring the decimal right on down. 8 and 3, okay? Just carry the decimal right down. So when you're adding or subtracting numbers with decimals, you just carry that decimal straight on down. Okay, again, you will have calculators to use on the exam, and I encourage them. I always say calculators should be a tool, not a crutch. You know, you shouldn't be dead in the water without the calculators, but obviously use them instead of doing stuff like this by hand, by all means, okay? All right, we're going to talk about taking averages on our next video. We're almost up to 20 minutes on this. Time flies, I'll tell you. So I'm going to end this one here and then start another one.